Welcome, geometry students, to the homework help video, page 348. Let's go ahead and get started with numbers 9 through 14. Okay, the directions say to use the top view of a conveyor belt in an assembly line to name the transformation. So we're going to start off with number 9. Okay, students, now for number 9, notice we're comparing A to B, okay? Be really careful. Here's A. Here's B. Now, first of all, students, notice something. Notice, notice, students, that the object has not turned, twisted, or rotated. It's facing the same way. All that you did was move it from here to here. So we obviously call that a translation, okay? A translation. Okay, number 10, we're comparing C to D. So here we go. Here's C. Now here's D. Now ask yourself a couple questions. Has the figure been turned or twisted? Yes, it has been. This figure is not facing the same direction as this one. Okay, fine. Number 2, ask yourself this question. Is there a line of symmetry that you can draw in which if you folded this paper right in half, this object here would fall directly, identically onto this object over here? No, not at all. If you were to fold this thing over, this thing would fall right over here. It would land right here. This circle would be right here. It just wouldn't work, okay? So the only thing left is a rotation, okay? So this thing here was rotated to here. It's a rotation. Learn to eliminate options, students, okay? That will help greatly. Okay, number 11, we're comparing B to C, okay? B to C. Now, the first question I'm going to ask you for number 11 is the object turned or twisted from the original object? Yes, it is. It's been twisted, so we know it cannot be a translation. Okay, I'll put a T right here. Cannot be a T, no way. Now, it cannot be a reflection. If you drew a line of symmetry here, and you fold this paper right on this line, this object here would not fall directly onto this object over here. This part right here with the circle would land about right here. And would come up, come over, look like that. It would not land perfectly on the other object, so we know it's not going to be a reflection. So it is a rotation, okay? It was rotated from here over to here. It is a rotation, okay? Alright, moving on to number 12. We're looking at B compared to E, okay? Number 12, B compared to E. Now, first of all, is this object here facing the same direction as the original object? Yes, it is. Now it's moved, it's slid down and over, but it's not been twisted, it's not been turned at all. It's not been rotated. This object here is facing the exact same direction as this one here. It's just gone down and then over. Alright, or you can say it went over and then down. We call that a translation, okay? That would be a translation. Okay, number 13, A compared to C. Here's A, and here's C, okay? We're going to compare A to C. Now, first of all, we start off by asking ourselves, has this object here, has this original object been turned or twisted to get this? Yes, it has. This object here is not facing the same direction as this object here, so we know it cannot be a translation. Is it a reflection? Well, if you were to draw a line of symmetry here and bend the paper right on that line, would this object here land identically on top of this object here? No, it would not. This part right here would land right here. It would go like this and come like this, have a circle right here. It would not land at all on top of that object. So it is a rotation. This key right here was rotated around to this point right here. So what we have, students, would be a rotation, okay? A rotation. Alright, number 14, we're comparing C to F. So here's C, and here's F way over here. Okay, it's hard to see, but in your book you should be able to see it, alright? Now, a couple things, students. know it's hard to see with my picture here, but if you were to put a line of symmetry right here, right in the middle of those two objects, and fold the paper in half, this object here would fall directly on this object right here, would fall right there, right there, right there, and the circle would land right there. So we do have a reflection, okay? We cannot have a translation because notice how the object is turned. This object here is turned compared to this one here. It is a reflection, okay? Reflection, okay? Moving on to numbers 15 through 18. Okay, we're going to use the figure to the right here to match the translation to this right here by the given vector, okay? So here we go. Let's see here. Okay, number 15. We're going to move this positive 1 and negative 3. So let's pick any point you want, doesn't matter. Well, let's pick A. So we're going to take A, and we're going to move A. Here it is, number 15, positive 1. To the right, then negative 3. So A went from here to here. Now what is that ordered pair called? It's called negative 4, comma 1. Do you see any answers over here that have A at negative 4, 1? This one right here. So that's good enough for me. Letter C is the answer. Alright, letter C. Alright, moving on to number 16. We're going to move it 0, 1. So we're going to take point A. We're going to move it 0 to the left and 0 to the right, then a positive 1. So it goes right there. Now the name of that ordered pair is negative 5, positive 5. So, do you see any answer over here in which point A has been moved to negative 5, 5? Well, yes, right here, letter D, negative 5, 5. So the answer is D. Okay, number 17. We're going to take point A right here. And for number 17, we're going to move it negative 1 and then negative 3. So A will fall right here, and that ordered pair is negative 6, 1. So we look over here for a point A that's negative 6, 1. Here it is right here. So the answer is A. So obviously the last answer then would have to be the letter B. But we'll go ahead and check it and make sure real quick. So for number 18, we're taking point A and we're moving it positive 6. And then negative 1. So there's where point A would be right there. And of course that's going to be positive 1, positive 3, positive 1, positive 3. And there it is right there. Okay, so the answer is B. Okay, so what we practiced there was taking a pre-image on the coordinate plane and then moving it so many units to the right or to the left or up and down. Okay, alright, moving on to number 19, 20, 21, and 22. Use a straight edge and dot paper to translate ABC. Okay, so here we go. Very quickly, we're going to take this triangle ABC. For number 19, we're going to translate it positive 2, positive 4. So this point goes over 2. I'm going to have to slide this down to get some work here. Okay, positive 2, positive 4. And actually, I'm trying to think. Hold on one second. Okay, students, I think that'll be a little easier to use. Okay, here we go. We're going to translate this triangle. Positive 2, positive 4, so over 2. 1, 2, up 4. 1, 2, 3, 4. So there's point A. Point B would be, or point C would be positive 2, 1, 2, up 4. 1, 2, 3, 4. So here's point C right here. And then point B would be positive 2, 1, 2, over 4. 1, 2, 3, 4. So there's point B right there. Okay? So, no, that can't be right actually. Let's try that again real quick. Positive 2. So, over 2 this way. 1, 2, and then up 4. 1, 2, 3, 4. So there we go. Triangle A. So point B would be right here. Now, point C would be positive 3, 1, 2, 3, negative 2, 1, 2, right here. So there's our new triangle for number 20, okay? That's number 20 right there. Alright, number 20. Okay, let's continue on. Let's take triangle ABC and let's translate it. Negative 1, negative 5, which is what 21 said to do. So point A goes negative 1, then 1, 2, 3, 4, 5. So there's point A. C would be negative 1, 1, and then 1, 2, 3, 4, 5. So here's point C way down here, okay? Now B would be negative 1, and then 1, 2, 3, 4, 5. So right here, okay? There we go. Okay, students. So we took the triangle ABC and translated it to negative 1, negative 5. Okay, students, moving on to number 22. We're going to take ABC and translate it. Negative 4, positive 1. So here's A, we'll go negative 4, 1, 2, 3, 4, and then positive 1. So there's A right there. C, negative 4, 1, 2, 3, 4, and then up 1. Alright? And now point B, negative 4, 1, 2, 3, 4, and then up 1, positive 1. There's where point B would be right there. So, there's your triangle. Right there. So we took triangle ABC, this blue triangle right here, and we translated it 4 to the left and up positive 1. Okay? I hope this is making sense, guys. It's not too difficult, really, okay? Alright, moving on to 23 through 26. If P is a translation of Q and they're different lines, then P has to be parallel to Q. Guys, that's true. Let's call this line P, okay? Now look, if you take this line right here, let me draw another one right on top of it. If you take that exact same line, okay, and you translate it over, up, here, I don't care where you put that line, it's going to be parallel unless you put it right here. But they covered that right here. They said that it has to be different lines. So students, listen, okay? Look, because this line here, it says, has to be a different line, and we're going to call this line Q, okay? So, no matter where you put this line, it will be parallel to Q. So yes, that's true. Okay. Alright, moving on to number 24. Okay, if line P is perpendicular to line Q, then P is not a translation of Q. Guys, that is so true. Look, here's line P. Here's the line Q, perpendicular. There's no way they can be a translation. Remember, in order for two lines, or for that matter, any two figures, to be translations, they have to be facing the same direction. And notice, these two lines are not facing the same direction. If they were facing the same direction, then they would look like this. Okay, like that. That's facing the same direction. Like that, then they're parallel. But these two lines, because they're perpendicular, they are not facing the same direction. Thus, they cannot be a translation, okay? They cannot be. Okay, moving on to number 25. If triangle ABC is a translation of DEF, and DEF is a translation of GHI, then ABC is a translation of GHI. Now, here's triangle ABC, and translation, here's DEF over here. So it's notice it's a translation because it goes down and then over like that, and then it says DEF is a translation of GHI. So maybe let's say it went down and over this way, and here's GHI, okay? So G here, notice they're all facing the same direction, then this triangle here will definitely be a translation of this triangle here because they're facing the same direction. So for this triangle here, we went down and then over to this triangle here. So guys, look, this is definitely true because if this triangle here translates to here, they're facing the same direction. And if this triangle here translates this triangle here, then they're facing the same direction. So this triangle here and this triangle here definitely have to be the same translation, okay? Alright, number 26. Number 26. If ABC is a translation of DEF, then, now watch this. Here's ABC. Okay, here's DEF down here. Now, please listen, students. Come on, guys, we've talked about this already. If C went down, I don't know, down 5 units and over 8, then that means A went down 5 units and over 8. And that also means B went down 5 units and over 8. We just talked about that. All the vertices here, here, and here move the same distances. So, if that's true, then the length of AD and I've got to fix these. I got these in the wrong order. There we go. Triangle ABC, DEF. Then AD has to be the same distance as CF, which has to be the same distance as BE. So is that true? Yes, it's true, guys. Definitely, because remember, all these vertices moved the same distance down and over. So yes, AD is the same length as CF, which is the same length as BE. Okay, so yes, this is true. Okay, that is definitely true. Alright, okay, let's continue on to the next problems here. Numbers 31 and 32. Now, in the directions it says that the length between L and M is 2. So, the length between, now watch this, L and M is 2. So the whole distance is 2. Now, if that whole distance is 2, from here to here, then look, notice we have 3 marks here and 3 marks here. No, we have actually 4 marks here. Sorry about that. But we know the whole length from here to here is 2, okay? Now that means, listen to me, students, that means anytime you put a 3-mark line and a 4-mark line together, you get a total of how much? 2. So here's a 3-mark line right here, and here's a 4-mark line over here. So if you put this together with this, that makes the whole thing become 4, okay? Because these two together are 2, and this would be 2 also. So the whole length from here to here has to be 4 all the way across. And by the way, that's the question, that's the answer to number 32. Number 32 says, what is the length of Q all the way to Q double prime? Well, the answer is 4. Now, look at this, guys. Look, from here to here is 2. That means anytime you put a segment with 1 mark with a segment with 2 marks, you get 2. Well, look, guys, this is a segment with 1 mark, and this is a segment with 2 marks here. So that means this plus this has to be 2, and from here to here is 2. So 2 plus 2 is 4. So this whole length from P all the way to P double primed has to be 4. From here all the way to here, okay? So this distance also has to be 4, okay? Alright, moving on. Okay, students, moving on to numbers 37 through 47. So here we go. Now, number 37. On number 37 and 39, they want us to give the vector, the translation vector. So blue is the pre-image. So we're going from here to here. Let's see. So we go to, notice every tick mark is 1. So we're going down 1, 2, and then we go across 1, 2, 3, 4, 5. Okay. So from here to here we went right. So it's a positive 5. And then from here to here we went down 2. So it's a negative 2. So the translation vector would be 5, negative 2. Okay. 5, negative 2. 5, negative 2. Now, moving on to number 39. Now, here's our pre-image, okay? Okay, students, let's go from this point here. Was moved to this point down here. So we went left. 1, 2, 3. So negative 3. And then we went down. 1, 2, 3, 4, 5. So negative 3, negative 5 would be the translation vector. Okay? Alright, now moving on to numbers 41 and 43. 41 and 43. Now, I went ahead and drew the triangle on a coordinate plane. Here's the triangle right here. A is 1, 4. B is negative 3, 2. And C is 5, negative 4. Okay? So there we go. Now, we're going to draw the translation. A is 4 and B is 3. A is 4 and B is 3. Alright, so we're going to put a 4, comma, 3. That's our translation. So A is going to go positive 4, 1, 2, 3, 4. Positive 3, 1, 2, 3. So there's A. B is going to go positive 4, 1, 2, 3, 4. Positive 3, 1, 2, 3. C is going to go positive 4, 1, 1, 2, 3, 4, and then up 3, 1, 2, 3 right here. So there we go. There's the translation of ABC. Alright, really just repetitive stuff here, guys. Not that difficult at all. Okay? Alright, let's go ahead and try number 43. Now here, notice on 43, they have a negative sign in front of B. So when I put 4 in for A, I have 4. When I put 3 in for B, that's a negative 3. So, let's go ahead and move this point here. Positive 4, 1, 2, 3, 4, then 3, 1, 2, 3. And then we'll move this positive 4, 1, 2, 3, 4, then down 3, 1, 2, 3. Point B, and then C would be 1, 2, 3, 4, and then down 3, 1, 2, 3. So about right here. So there we go. There's the translation of ABC. Again, guys, pretty simple stuff, okay? Alright, 2 more problems. Let's see here. Directions say 2. Okay, no, guys, here the directions say that they're giving you the last image. Go backwards and find the pre-image, okay? Now look, please listen, students. Usually, if I gave you the beginning image and I said point A is at 3, 2, and you move negative 2, you would subtract 2. But students, listen to me. We're going backwards. If you read the directions, they're giving you the last image, okay, the second image, and you're trying to find the pre-image, so we have to go backwards. So instead of subtracting 2, we're going to add 2, and when you add 2, you get 5. And then instead of adding 1 to the 2, we're going to subtract 1 from the 2, because look, this is your translation vector. The only thing is, these points right here are not your pre-image, they're your ending image, your last image. You're trying to go backwards and find the pre-image. So instead of adding 1 to the 2, it's a positive 1, you're going to subtract 1, which would give you a 1. Okay, same thing here. Instead of subtracting 2, add 2. So negative 3 plus 2 would be negative 1. And then instead of 4 plus 1, it's 4 minus 1. That would give you a 3. And then instead of 6 minus 2, it's 6 plus 2. That would be 8. And then instead of negative 1 plus 1, it's negative 1 minus 1. That would be negative 2. Now, if that confuses you, look at it like this. Watch this. These points lines here are your pre-image. These are your starting image. So how would you find the ending image? Well, you would take 5 minus 2 and you would get 3. And then you would take 1 plus 1, you would get 2. So it totally works, okay? Alright, let's try one more. It's the same thing, okay? So instead of 2 plus 2, it's 2 minus 2. That would be 0. Instead of 1 plus 3, 1 minus 3 would be negative 2. We're just going backwards. Instead of 4 plus 2, it's 4 minus 2. That's 2. And instead of 4 plus 3, it's 4 minus 3. That would be 1. And then instead of negative 3 plus 2, it's negative 3 minus 2. That's negative 5. And then instead of 1 plus 3, it's 1 minus 3. That's negative 2. And then instead of negative 3 plus 2, it's negative 3 minus 2. That's negative 5. And instead of 4 plus 3, it's 4 minus 3. That would give you 1. Okay, so there we go, guys. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.